first construction is going to deal with the point of concurrencies, which is called the circumcenter. And what we're going to do is we're going to construct the perpendicular bisectors of each side of a triangle. So to start with, I'm going to bisect each line segment that comprise the sides of the triangle. I'm going to start by bisecting the segment from A to C. So I'm going to pivot on A, and I'm going to swing an arc that's clearly more than half the length of the line over towards C. I'm going to swing above and below the line. Then I'm going to come to C and pivot, swing that same distance arc above and below the line. And what I'm going to do is I'm going to connect my perpendicular bisector points. I've created the perpendicular bisector to line AC. Okay. The next thing I'm going to do is I'm going to do the perpendicular bisector for line segment AB. So I'm going to take my compass, I'm going to pivot on point A, and I'm going to swing an arc that's clearly more than half the distance to B. I'm going to swing the arc above and below the line. Then I'm going to come pivot on point B and swing an arc above and below the line. Then I'm going to connect my line through those two intersections. Okay, so right now I've got two perpendicular bisectors. I need to do the perpendicular bisector for segment BC now. So I'm going to come pivot on B. I'm going to swing an arc that's clearly more than halfway to C. And I'm going to swing above and below line segment BC. Then I'm going to come pivot on line segment on vertex C. I'm going to swing an arc above and below line segment BC. Then I'm going to come back and I'm going to connect the line segment that goes through those 2 points of intersection. And what I've found is these three perpendicular bisectors share a common point of concurrency. And my point of concurrency is here. Now, I drew an obtuse triangle so it can land inside or outside. Obtuse triangle, my point of concurrency can land outside. If it was an acute triangle, it would land inside. Now, what's significant about this point of concurrency is if I take my compass now and I pivot on my point of concurrency, and I'm going to extend my compass so it set the distance between the point of concurrency and my vertex. And a little bit short. Okay, and make this one black. Okay, so I'm pivoting on my point of concurrency to my vertex. If I swing that all around, what we're going to find is that point of concurrency is the center of the circle that circumscribes the triangle. It's equidistant to each vertex. So this is the center of the circumscribed circle. Equidistant to each vertex.